In the previous videos, we've seen how we can use distance formula to prove things in geometry. In this video, we'll try proving the same things without using distance formula. So here's the first one. Without using distance formula, show that the points 3, 0, -2, -2 and 8, 2 are collinear. Collinear means all three of them are on the same line. So if we visualize these 3 points, we have the x-axis, y-axis, 3, 0 is on the x-axis, 8, 2 is in the first quadrant, -2, -2 is in the third quadrant. And if we try drawing a line that passes through the first two, this line will also pass through the third one, which means all three of them lie on the same line. All three of them are collinear. But this is a visual way of doing things. We are asked to prove this without using distance formula. Now for a minute, if you want to refresh how we use the distance formula to figure out this, to figure out that these 3 points are collinear. Now as a quick refresher, the way to do this using the distance formula would be like this. We'll say that these 3 form a triangle. 3 points on a plane will form a triangle. And we'll find the lengths of these sides of the triangle. If the sum of 2 sides is greater than the third side, we say that this is a triangle. If that's not the case, if the sum of 2 sides is exactly equal to the third side, we say that they do not form a triangle, which means the triangle collapses, which means that they are collinear. Which is the case here. Look at it. These 2 form side 1. These 2 form side 2. Now the sum of these 2 sides, side 1 and side 2, is exactly equal to the third side, which is formed by this point and this point. So sum of 2 sides is exactly equal to the third side, which means they are collinear. We don't get a triangle. But we're asked to do this without distance formula. So how do we do this? Pause the video, think about it. What other concept that we have learned in straight lines can be applied here? Okay, so here's the clue. If we form a line that passes through these 2 points, we'll get some slope. That will be the slope of this line segment. Now if we continue moving along the same line, this means that we don't change our slope. This means that the slope of this line segment, that's between 3, 0 and 8, 2, the slope of this line segment is exactly same as the slope of this line segment. If that's not the case, if we change the slope, then we deviate from the path and we don't get a straight line. So to get a straight line, both these slopes should be equal. Now can we figure out the slopes? Yes, we can. We can use the coordinates of these 2 points to figure out the slope of this line segment. We'll do the same here and then we'll compare. If the slopes are same, they are on the same line. If the slopes are different, they're not on the same line. Okay, so let's do that. Slope formula is y2 minus y1 by x2 minus x1. Let's use that for these 2 points first. We have m1, which is the slope of this line segment. That's 0 minus -2, the difference in y coordinates, divided by 3 minus -2, the difference in x coordinates. So that's going to be 0 plus 2 by 3 plus 2, that's 2 by 5. So the slope of this line segment is 2 by 5. So we've moved from this point to this point along the line with slope 2, 5. Now we are moving from this point to this point and we are maintaining the slope. We're saying that we'll continue moving along this line, so the slope will remain 2 by 5. Let's see if that's really the case. The slope of this line segment is 2 minus 0 by 8 minus 3. That's 2 by 5. So that's also 2 by 5. Now the slopes are same, which means from this point 3, 0, and there's exactly one line that passes from a point with a fixed slope. So if this line passes through these 2 points and it passes through these 2 points, this means that it passes through all 3 of them, which means equal slopes and same point. So they lie on the same line. So that's how we prove using the concept of slopes that these 3 points are collinear. Let's take another example. Without using distance formula, show that the points 4, 4, 3, 5 and -1, -1 are vertices of a right angle triangle. So here's the visualization. -1, -1, 4, 4 and 3, 5. They do look like that they are vertices of a right angle triangle, but how do we prove it? First, let's recap. How do we prove it using distance formula? Well, a right angle triangle will have Pythagoras theorem applied. So if we square the sides and add them, we'll get the square of the hypotenuse. A square plus b square equals to c square. So we'll figure out the lengths of these three using distance formula and then compare whether the sum of these two squared is equal to the square of this side. But we are asked to do this without using distance formula. So what other property of a right angle triangle that we can apply that does not involve distance formula? Pause the video, think about it. Okay, so there's one more thing that we can apply. This angle right over here, this is 90 degrees, which means these two lines are perpendicular lines. And if they're perpendicular, we can say that the slope of this line and the slope of this line are related. And what's the relation? For two perpendicular lines, the product of their slopes is equal to -1. Now, if this is really the case, we can say that these two are perpendicular, which means that we do have a right angle triangle. And if this is not the case, if this is anything but -1, we'll say that these two lines are not perpendicular, which means we don't have a right angle triangle. So now our job is to figure out the slopes of these two lines. First this one and then this one. So let's do that. We'll use this formula. Slope of this line m1, this is equal to 4 minus -1 divided by 4 minus -1. That's 5 by 5, that's going to be 1. What about the slope of this line? This is equal to 4 minus 5 by 4 minus 3. Both will give the same answer. So this is -1 by 1. The slope of this line is -1. Now if we multiply, we get 1 times -1. That's actually equal to -1. So using the slopes, we've figured out that these two lines are in fact perpendicular, which means they do form a right angle triangle. Let's take one last example. Without using distance formula, show that the points -2, -1, 4, 0, 3, 3, and -3, 2 are vertices of a parallelogram. Here's the visualization. Here are these 4 points, and they do look like they lie on the vertices of a parallelogram. So how do we prove it? First, let's recap. How do we prove it using distance formula? Well, opposite sides are equal in length, which means if we can figure out the lengths of all 4 of these sides and compare the opposite lengths, and if they're equal. So if this blue length is equal to this blue length and this white equal to this white, we'll say that this is a parallelogram. If that's not the case, we'll say that this is not a parallelogram. So how do we do this without distance formula? What other property of parallelograms we can use here? Pause the video, think about it. Okay, the clue is in the name itself. The opposite lines are not just equal, they're parallel as well. So opposite sides are parallel, which means they have the same slope, which means the slope of this line is same as the slope of this line, and the slope of this line is same as the slope of this line. If we prove that opposite sides have the same slope, then we have proved that this is in fact a parallelogram. So let's do that. Let's find the slopes of all 4 of these lines and see which of these are equal. We'll use this formula. Let's start with this one. Slope of this line will be 0 minus -1 by 4 minus -2. That's 1 by 4 plus 2 is 6. So that's 1 by 6. Let's hope that this line also has slope 1 by 6. So let's calculate. That's 3 minus 2 by 3 minus -3. We have y coordinates on top and x coordinates on the bottom. 3 minus 2 is 1. 3 plus 3 is 6. So the slope is 1 by 6. So these two have the same slope. Now let's check the white ones. Slope of this line is 3 minus 0 by 3 minus 4. That's 3 by -1. That's equal to -3. Let's see what the slope of this line is. We have 2 minus -1 by -3 minus -2. So 2 plus 1 by -3 plus 2. The numerator is 3 and the denominator is -1. So we get -3 here as well. This means the slope of these two lines are also equal. So the slopes of these two lines are same and the slope of these two lines are same, which means opposite sides are parallel, which means we do have a parallelogram.